lesson 7.2, Solve Linear Systems by Substitution, you should be on page 435. You have just completed a lesson solving linear systems by graphing. Substitution, in my opinion, is a more efficient way of solving a system by graphing. Now, to substitute, you're going to see here it's a three-step process. The first step, you want to solve one of the two equations in your system for one of its variables. When possible, solve for the variable that has a coefficient of 1 or -1. Now, a couple things to review there. Remember, the word coefficient means number in front of variables. So if you look at either equation and you see a variable that would have a 1 or nothing in front of it, which means 1, that's the variable you should make sure you isolate. You might be wondering, well, why would I do, what's the point? Well, it's less work for you in this method if you do that. I'll show you that in a minute. The second thing, substitute your expression that you developed from step 1 into the other equation and solve for the other variable. And then step 3, substitute the value from step 2 into the revised equation from step 1 and solve. Now, if you have not done substitution before, as you're reading this, you're probably like, that doesn't make any sense. Like, what the heck? Let me show you. I think showing you will make these 3 steps easier. I would pause the video right now and write these 3 steps down, even if it doesn't make sense. So pause and do that. Okay, we're back. So let's actually look at these 3 steps in an actual problem. So we're going to do this next problem together, and we'll talk about these 3 steps. So we want to solve the system. So step 1, take one of your 2 equations and make sure you solve for one of the variables. Now you notice in this problem, the first equation, y, is already isolated. So step 1 has already taken place. In fact, I'm just put a little check mark next to it up here. We've already done step 1. It's already like that. Y is by itself. All I got to do is get one of the equations, have one variable isolated. Now step 2, y is the same thing as 3x plus 2. So substitute 3x plus 2 in equation 2 for x. So again, if you're like, what are you talking about? Y and 3x plus 2 are the same thing. So take 3x plus 2, substitute it into equation 2 where you see a y, because y can be replaced by 3x plus 2. They're the same thing. So you notice right here, I'm going to circle it, this equation, you can see instead of having a y, they replaced y with 3x plus 2. Replacing is the same as substituting. Now the next step, simplify and solve. Distribute. So you get, let me write it up over here, you'd get x plus distributing 6x plus 4 equals 11. And you notice that would be 7x plus 4 equals 11, which is what they have here. And then you can take away 4, divide by 7, and you're getting x is 1. So x is 1. So we've done step 2. We substituted, and we found what our one variable. X is 1. Now we got to figure out y, which gets us to step 3. Take x is 1, substitute x is 1 in for x, and solve for y. So in other words, if I go back to y equals 3x plus 2, I can substitute a 1 in for x. You can see they're doing that here. They're putting 1 in for x. 3 times 1 plus 2 would equal 3 plus 2, which is 5. We just figured out y is 5. So x is 1, y is 5, and you can write that as an ordered pair. Okay, let's check our answer. Is 1, 5 a solution to the system? Let's try it. If I put a 1 in here and a 5 in here, is that true? Is 3 times 1 plus 2 5? Yeah, it is. Okay, let's try over here. If I put a 1 in for x and a 5 in for y, is 1 plus 2 times 5 going to give me 11? And yes, it is. 10 plus 1 is 11. So there's my solution to my system. So step 1, isolate a variable. either x or y, it doesn't matter. Get one variable isolated. Step 2, substitute that expression into the second equation. Step 3, once you solve for one of the variables, substitute that in to find the second. Okay? Let's do another one. I'm just going to, again, you don't have to write that down, but just watch and listen. So in this problem, step 1, remember step 1? We want to get one of the variables isolated. Do you notice here how x is the variable that has a coefficient of 1? If I just quickly add 2y to each side, I'll get x equals 2y minus 6. I just took care of step 1. I have isolated x. So x is the same thing as 2y minus 6. So you'll notice I take 2y minus 6 from my first equation and I substitute it in for x in the second equation. That's why I have 4 times 2y minus 6 plus the 6y equals 4. Okay, all you have to do now is distribute, simplify, and solve, which they're doing here, and that, when I do that, you can see here, I'll show the work. 8y and 6y is 14y minus 24 equals 4. Add 24 to each side, so 14y equals 28. Divide by 14, you can see y is 2. Okay, there's step 2. I substituted and solved, y is 2. So now my last step. Take 2 for y, plug it into our original statement up here. Plug in 2 for y, and 2 times 2 is 4. 4 minus 6, negative 2. X must be negative 2, so my ordered pair would be x negative 2, y 2. That should be the solution. Let's check it real quick. Now I already know this works in the first statement, because that's where I derived it from. Let's see if it works in the second equation. I'm going to put a negative 2 in for x. 4 times negative 2 is negative 8, plus 6 times y is 2. 6 times 2 is 12. Does negative 8 plus 4 give me 12? Yes, it does. There's my solution to the system. Negative 2, negative 2. Okay? Let's do another one. Let's do a couple more here. Let's solve these. We're going to do 1 and 2 together. Let's solve the linear system using substitution. So step 1, we have to isolate a variable. Well, what a gift. Do you notice the first equation, y is already isolated. So step 1's done. I already have a variable isolated. Y is by itself. Okay, so now I got to substitute. I'm going to go to a new sheet. So y equals 2x plus 5 and 3x plus y equals 10 are my equations. So let's take 2x plus 5, which is the same thing as y, and substitute it into the second equation for y, which gives me 3x plus 2x plus 5 equals 10. Now I'm going to solve. So simplify first. You notice 2x and 3x add up to 5x, plus 5 is 10. Subtract the 5 from each side. Divide by 5, and x is 1. Now, I got to find y. So take 1, plug it in. So 2 times 1 plus 5 would equal y, and that would be 2 plus 5. Y must be 7. So my ordered pair must be 1, 7. Let's check and see if that works in the other equation. So let's check and see if this works here. 3 times 1 is 3 plus y is 7. Does that give me 10? And yes, it does. So there's my solution, 1, 7. Here's another problem. X minus y equals 3, x plus 2y equals negative 6. I would recommend solving for x in either equation. I decided the first equation looked easy. So if I just add y to each side, x would equal 3 plus y for the first equation. Now I'm set to substitute. I have x by itself. So let's go to another sheet here. I'm going to take this equation and this and write them out. So there they are. Let's substitute. 3 plus y is the same as x. So go ahead to the second equation where you see x, substitute in 3 plus y. So you notice I substituted 3 plus y in for x, and I get 3 plus y plus 2y equals negative 6. I can combine y and 2y together. 3y plus 3 equals negative 6. I'll take away 3, and I'll divide by 3, and y is negative 3. Now I got to find x. Take negative 3 for y, plug it in here, and see what x is. 3 plus negative 3 is 0. It looks like my ordered pair is 0, negative 3. Let's see if that works in the other equation, in this one. If I plug a 0 in for x, I get 0. If I take 2 times negative 3, I get negative 6. Is 0 plus negative 6 equal to negative 6? And yes, it is. There's my solution, 0, negative 3. This is called the substitution method. You will have a few word problems to do. Now again, the hardest part of these would be just setting up the equations. Once you set up the equations, you can substitute. So like in this question, many businesses pay website hosting companies to store and maintain the computer files that make up their websites. Internet service providers also offer website hosting. The cost for website hosting offered by a website hosting company and an internet service provider are shown in the table. So here are the two companies offering these services. Here's the first company, here's the second. Find the number of months after which the total cost for a website hosting will be the same for both companies. So this first company is saying the cost, let me write it out in words, the cost would equal the setup fee plus the cost per month. So we can see that here. The total cost is Y. The setup fee for company 1 is $10, plus the cost per month would be $21.95 times, I don't know how many months, that's why I put X. So there's the first company's equation, Y equals 10 plus 21.95X. There's company 1's equation for their service cost. Okay, let's go to the second company. Same kind of setup. Their cost, let me do it in a different pen color. Their cost would be the setup fee, which is 0, so that's why we have nothing here, plus the cost per month times the number of months, which is 2245X. So there's provider 2's equation. This is perfectly set up for substitution. I already have a variable isolated. All I have to do is take a highlighter here. If I just take 2245X and I substitute it in here for Y, which you see they're doing right here, all I have to do is get all my variables on one side now, so take away 2195X, and that gives me 0.5X equals 10. I can divide by 0.5. I just found, 0.5. I just found out X is 20. So if X is 20, okay, then that's saying that I have 20 months, because X is the months, I have 20 months in which the price would be the same. Now, what's the total cost? Well, let's quickly check it out. If I put 20 in for 20 in for X, 2245 times 20, and when I plug that in my calculator, I'm finding out that after 20 months, both places would provide me service for $449. So there's my ordered pair for that. Last problem, mixture problem. You did these earlier in the year, and we're going to do them again. I think they're a little easier to solve now that we know how to solve a system than it was with just one variable. For extremely cold temperatures, an automobile manufacturer recommends that a 70% antifreeze and a 30% water mix be used in the cooling system of a car. How many quarts of pure 100% antifreeze, which you see here, you remember us drawing these pictures earlier in the year, and a 50% antifreeze and 50% water mix, which you can see here, how many quarts of each should be combined? Now think about it. What arithmetic is combined? I hope you're coming up with adding. So we're adding these together. and we want to make, and I'll do this in orange, we want to make 11 quarts of a 70% antifreeze and 30% water mix. So there's my statement. Now let's think about this. This is how I wrote it out earlier in the year. I don't know how many quarts of this I have. I call it X. I don't know how many quarts of this either. I'll call this Y, and there's 11 quarts in this container. There's your first equation right there. X plus Y has to equal 11. Okay, now your second equation is an acid equation. All right, I'll use an acid equation. Or I guess antifreeze, I ought to say. We're doing antifreeze problems. Okay? The first container is 100% antifreeze, so I would put 1x because 100% of this is antifreeze. Plus, this container is 50% antifreeze, so I'll put 0.5y should equal this container, which is 70% antifreeze. So 0.7 of the 11 quarts is antifreeze. There's your two equations. So all you have to do is solve the system. So you might want to isolate x or y in the first problem, which you see here. They decided to isolate x. They put x as 11 minus y. And then they took 11 minus y and they substituted in for x in the first equation, which you can see here, and then they solved. I'm going to pause the video here. If you have questions, make sure you ask in class.